Hello guys, welcome back to ChemOrgChem. As you know, we have been exploring into the problem solving for name reaction featuring organometallics. In last series, we tackled the Negishi cross-coupling related problems. In today's session, we are moving on to the Tsuji-Trost Allylation related problems. If you are new here, don't forget to subscribe ChemOrgChem. Let's moving to the today's question. So this is the question from CSIR 2015. As per this question, this allyl substrate react with palladium acetate, triphenyl phosphine, triethylamine and acetonitrile which produce a product. So here you can see that there are four options are given. Let's solve together to find the correct option for this question. So once you see this reaction condition as well as the substrate, most of them get sense about this reaction. So this reaction is Tsuji-Trost Allylation reaction. We have already discussed Tsuji-Trost Allylation reaction, catalytic cycle and their magnetic detail along with various examples. If anyone missed that video, you can find the link in the description box below. As per this reaction requires palladium zero catalysis. Palladium zero can be generated by reacting palladium acetate with triethylamine or palladium acetate with triphenyl phosphine. If palladium acetate react with triphenyl phosphine, that can produce palladium tetracase. When two ligands dissociate to produce their corresponding palladium zero active catalysis. So now our substrate interact with our palladium zero catalysis which undergo association reaction to produce this corresponding palladium pi complex. So this particular step undergo by stereoselective fashion. So now you can see that here acetate group present at the top phase. Therefore our palladium zero species should interact this alkene by bottom phase. So resulting that generation of this intermediate. So the next step of the reaction would be a oxidative addition. So resulting that generation of eta 3 allyl cationic complex. So the next step of the reaction would be a nucleophilic addition. So here you can see that so this amine acts as a nucleophile. Therefore we can say that intramolecular Tsuji-Trost allylation reaction. So here there are two sites are there. One site is here and another one is here. So when you start the numbering, you will get fifth position to this carbon and seventh position to this carbon. However, the formation of 5-membered ring system is favored. Therefore, amine nucleophile attack the fifth carbon rather than seventh carbon. So this particular attack takes place at top phase manner since bottom phase occupied by palladium species. So resulting that generation of this intermediate. Next step which quickly undergo dissociation in order to release the palladium zero catalysis regeneration along with generation of our final product. So when you redraw this final product like this, so now you can see that two hydrogen atom present at the bottom phase. Let's moving to the our question. As per our discussion, among the four answers, the correct option for this question is option 2. That's it for today's problem. I hope this video has helped you to understand this reaction. So if you enjoyed this session, just give it a thumbs up and share it with your friends, and don't forget to subscribe ChemOrgChem for much more questions like this. And finally, thanks for watching. Bye bye.